Hi, I'm Jonas, also Zimbabwean on the internet. Just a quick survey first. So who's using Dockerfiles in their day-to-day? So like 80% of the room. And who's using Nix in their day-to-day? So one hand. All right, so this is basically 8 months ago, I was really interested in Nix, and I decided to quit my job and do Nix consulting. And that's a bit of the story. So I found a couple of customers. One of the bigger one is Alpha Sheets. They are a San Francisco startup, and they're building Excel on steroids, which is basically allows you to run arbitrary code in an Excel sheet on the web. And the problem they had is they wanted to package all of this. They have R, Python, lots of backend stuff. And in the end, deploying on Kubernetes. And so the talk is about how you can use Nix as a replacement for Dockerfiles, basically. But first, so what is Nix? Nix is a build system and a package functional language. And it gives you nice properties, like it's composable and you can have reproducible builds. And so how do you achieve that? So in normal build systems, like a makefile, usually all your output is in the project folder, whereas here, it's all going to be inscribed into the Nix store. So it's an absolute path where all the build inputs is specified, and the Nix store is going to store, the key is going to be the hash of the build inputs, and then the output, the value is going to be the sandbox build of the build inputs. And this gives you nice properties that I'm going to show you. The language is a little bit weird. It looks, it's a bit like JSON with functions. But it takes a bit to get used to, but it's actually fairly simple to learn. And so because Nix is pure, you specify everything, and you don't want to write packages for Ruby, Python, and Haskell. So there's actually a package repository that's maintained by the community, and I'm one of the contributors. We have 12,000 packages, and we have security updates. And we also provide binary cache, which is pre-built binaries for all of the packages in the package repository. So if you use Nix packages, you can just pull the binaries and you don't have to build everything yourself. So I wanted to show you how to do it, but obviously I don't have access to the source code of, or I can show you the source code of Alpha Sheets. So I decided to build a little app using the to-do MVC project. And this is the source code. It takes all the to-do MVC and then just add some Nix on top of it. So basically, you have a monorepo with a couple of services. And then you build a Docker image, push to the registry, and deploy the changes. And the thing I'm really talking about is the first bit where you build the Docker images, and then at the end it's going to stay the same. You know, you can deploy to Kubernetes or whatever. And so some of the properties that you want from the build system is, you know, to only build the things that have changed. For example, if you have two services like front-end and back-end, when you push new code, you want to avoid building new images for both of the things. You want to just run the test when they change. You want to, yeah, I'm just repeating myself, but sorry. One important aspect is that if you have security updates, you want all of the containers to be updated, or at least the ones that have the security updates to be deployed to. And as a developer, you want the application dependencies to be available, which means that as a front-end guy, you want to pull all the dependencies and then reduce the priority. And if possible, you want to be able to have the CI prepare the binaries so that you just, as a developer, you just pull the pre-built binaries. All right. So, can you read it? Okay, so that's the to-do MVC project. So that's done. That's almost done. And right now, what I did is I took the Haskell implementation of the backend, and you can see there's a common library and then a backend. That's the actual web server. And then the front end is just a JavaScript with nothing special like it. And then what I did is I just created a Nix folder. And in here, I describe how to build the front end. So that's what you saw previously. Just to decipher a little bit, that's all the build inputs at the top. And the whole file is a function. And that's all the parameters to the function. And then I say, it's a Yarn project, so I use the Yarn log file to pull all of the dependencies. And the build is just to Yarn build. And then it writes to the output. And the output is, you remember when I had the hash with the key and the value? The output is going to be the value. The backend is pretty much the same, but we have two components. And then I tie them together here. And then on the top level, we have the all packages, where I pull the front end, and I build the Docker images for the front end. And the back end, the Docker image for the back end. And finally, the top level is this file that takes the Nix packages. And then what we do is we take all of Nix packages and build an overlay on top of it with our own packages. And we export them all in this file. So it seems a bit complicated, and actually it's a bit more work than just putting Docker files together. But once you have that, it works pretty well. Okay, so if you have a CI like Jenkins or whatever, you just execute this file, and this builds the release. And we get all of the front-end, back-end, the Docker images and everything, and then we can push them to the registry. So yeah, we get all of this for free. But obviously, it's quite a new technology, so there's some downsides. Like, it's not mainstream. Your developers need to install Nix on their machines. You have some missing tools. But yeah, that's it.